So this is the video for section 3.4. Previous one that was uploaded did not have audio for some odd reason. So here we're going to be talking about the slope of the tangent line, which is just the limit of f of a plus h minus f of a over h as the limit as h approaches 0. Now the tangent line, the graph of the function y is equal to f of x at the point a and f of a is the line through the point having this particular slope. So whatever the value is that comes out of this limit, that is the slope of the tangent line. Now, the derivative of a function of f at a point x, or a value x, is defined as f prime of x is equal to the limit of f of x plus h minus f of x over h as h approaches 0. Now, this is only if the limit exists. So then, using that information, for number 11, we can go ahead and find f prime. So f prime of x is equal to the limit as h goes to 0 of 3 times x plus h minus 7, and then 3x minus 7, right? So we're going to have that there, and we divide everything by h. So we repeat the process over here. So this will be 3x plus 3h minus 7 minus 3x plus 7 all over h. So now we can go ahead and combine like terms. So the 3x's, right? 3x is going to cancel each other out. The 7's are going to cancel each other out. And so we're going to be left with 3h over h, which is just going to be 3. And so if the function f of x is defined to be 3x minus 7, then f prime of x, which is the derivative of the function, is just going to be 3. And then so if we do number 12, same thing here, right? So f prime of x is equal to the limit of negative 2x plus h plus 5 minus 2x plus 5, right, all over h. And so again, this is the limit as h goes to 0, and it's going to be negative 2x negative 2h plus 5 plus 2x minus 5, right? I have to distribute that minus, or that negative 1, if you will. So I'm going to cancel out the negative 2x, and the 2x are going to cancel each other out. The 5's are going to cancel each other out, and I'm going to be left with negative 2h over h, which is just going to be negative 2. Now, since both of these functions end up being constant, then the values for each one of these would just be what the function is, right? For this particular one, f prime of negative 2 is going to be equal f prime of 0, which is going to be equal to f prime of 3, which is going to be equal to 3. So the same thing here, since it's a constant function again, f prime of negative 2 for this particular one is going to be equal to f prime of 0, equal to f prime of 3, which is going to be equal to negative 2 for these particular functions. Now, looking at number 14, we're going to go ahead and do exactly the same thing, right? So we're going to have f prime of x is equal to the limit as h goes to 0 of 6 to second power minus 5x plus h plus 1. So what happens here is that you can get a little bit confused with the algebra because you're going to have a lot of terms all over the place. So you just have to be careful when you are working these out. So this becomes x squared plus 2xh plus h squared minus 5x minus 5h plus 1 minus 6x squared plus 5x minus 1 all over h, right? So now what I'm going to do is I'm going to distribute the 6. So it's going to be 6x squared plus 12xh plus 6h squared minus 5x minus 5h plus 1 minus 6x squared plus 5x minus 1 all over h. So now what's going to happen here is that I'm going to go ahead and cancel out the ones that I can, the ones that are pretty obvious. So the 6x squared, The 5x is going to be also canceled out. The 1s are going to cancel each other out, right? And so we double check everything. There's nothing else that I can cancel out at this point in time. So it's going to be 6h squared, sorry. Be 6h squared plus 12xh minus 5h all over h, right? And if we cancel out an h, we'll be left with 6h plus 12x. Let me write this way here a little better. So it's going to be 6h plus 12x minus 5, which is going to be 12x minus 5. So if the function, which is going to be equal to f prime of x, right? So if the function is 6x squared minus 5x plus 1, then f prime ends up being 12x minus 5. So then f prime of negative 2, right, it's going to be negative 24 minus 5, which is negative 29. F prime of 0 is just going to be negative 5. And f prime of 3 is going to be 12 times 3 minus 5, which is going to be 31. Okay, going over to number 15. I'm going to do number 20 for you guys for extra credit for that one. So then f prime of x is going to be equal to 12h, right, minus 12 over x over h. Let me fix this one over here. So f prime of x is equal to the limit as h goes to 0. So then I'm going to go ahead and combine my numerator here. So this is going to be 12x, right? And then x plus h minus 12x plus h over x plus h all over h. So I just gave the denominator to each one, so I can go ahead and combine that into a simple fraction, or just a fraction here real quick. So then this will be 12x, right, minus 12x minus 12h all over x plus h over h. And so here we're going to end up with negative 12h over x plus h over h. And so now what I'm going to do is kind of clean this up just a little bit. So it's going to be x squared plus xh over h. And so then this is going to be x squared plus xh plus 1 over h. And then here it's going to be negative 12 over x squared plus xh, which is just going to be negative 12 over x squared. So if the function is defined as to be 12 over x, then f prime of x, or the derivative of the function, ends up being negative 12 over x squared. Let me just rewrite that a little better. Right? And then, of course, you can evaluate the values here. So let's look at number 17. So f prime of x would be the square root of x plus h minus the square root of x over h. So what I'm going to do is I'm going to rationalize the numerator, right? So I'm going to multiply by the conjugate x plus h plus square root of x, which is then going to give me, let me put it over here. So in this case here, square root of x plus h plus square root of x plus h is going to be x plus h, right? Minus, plus square root of x plus h, minus square root of x plus h, right? Minus x, right? Because square root of x times square root of x is just going to be x all over h, right? All over h, and then of course I'm going to have x plus h plus square root of x, right? And so these terms are going to cancel each other out. You can see here how these two terms are going to cancel each other out. And then the negative x is going to cancel, the x and the negative x are going to cancel each other out. So I'm going to be left with h, right, over h square root of x plus h plus square root of x. And of course, if it's the limit, as h goes to 0, then this is going to be 1, right, over square root of x plus square root of x, which is going to be equal to 1 over 2 square roots of x, which will be your f prime of x. So if the function is defined to be square root of x, then the derivative of that would be 1 over 2 square roots of x. All right, number 18, 25 I'm going to leave as extra credit. So here's the nice thing about this one. So we already know that if the function f of x is the square root of x, I can evaluate this one basically the same way as I did the previous one. Let me just do this here so I can have my space. So we know that if f prime of x is equal to the square root of x, sorry, not f prime, f of x, then f prime of x is equal to 1 over 2 square roots of x. So then, if I were to evaluate this one, we're actually going to end up with a negative 3 over 2 square roots of x, right? And so here I'm going to have negative 3 x plus h, right, minus negative 3 square roots of x all over h, right? Of course, I keep forgetting to write the limit. So f prime of x is the limit as h goes to 0, right? And so I am going to end up with negative 3 x plus h plus 3 square roots of x over h. Now, if I multiply by the conjugate, right, which will be minus, so it's going to be x plus h plus 3 square roots of h over h, negative 3 square root of h plus h minus 3 square roots of x over x plus h minus 3 square roots of x. And so what's going to happen here is that I am going to end up with, so if I do negative 3 square roots of x plus h times negative 3 square roots of x plus h, I'm going to have 9 x plus h, right? And then the two middle terms are just going to be negative, right? So if I do negative 3 square root of x plus h times negative 3 square root of x, that's going to be, actually this should have been, yeah, that's fine. So the conjugate, so the middle terms are going to cancel each other out, right? And so we're going to end up with negative 9x over here, and then this is going to be h, negative 3x plus h minus 3 square root of x. Now, so remember, so 3 square root of x times negative 3 square roots of x is just going to be 9x, right? Because the square root of x will, the radical will cancel out. The reason we multiply by the conjugate is because the signs, the middle terms end up canceling each other out. And so I end up with 9x plus 9h minus 9x over h, negative 3 square roots of x plus h minus 3 square roots of x, which is 9h over h, negative 3 x plus h minus 3, right? And so the h's are going to cancel each other out. I can also take out a negative 3. The h cancel out. I'm going to take out a negative 3 here. This will be square root of x plus h minus square root of x. And so, plus square root of x, sorry. And so now this is gonna they're gonna cancel each other out, aren't they? Right. So they're gonna reduce. So it's going to be 3 or negative 3 square root of x plus h plus square root of x, which is going to be 2 square roots of x, negative 2 square roots of x. So we get the same result, but with the constant in the denominator, in the numerator. So that's a pretty good result. All right, I'm going to go through 21 instead of doing it step by step, and also number 23. I'll go explain those. So number 19, we're going to do the same thing, right? So here, you have to be careful because you're going to have x to the third power. So f prime of x equals the limit as h goes to 0 of 2x plus h to the third power plus 5 minus 2x to the minus 2x to the third plus 5 all over h. And so if we were to expand that, the x plus h, right, to the third power, there's several ways that we can do that. Now, one way that we can do it is just to multiply, do x plus h times x plus h times x plus h. But there's actually, an easier way of doing it. So this is going to be equal to the limit as h goes to 0 of 2, and then this will be x to the third plus 3hx squared plus 3h squared x plus h cubed plus 5 minus 2x to the third minus 5 all over h. And so now we can distribute the 2, right? I'm hoping that I can get to it. So it's going to be 2x to the third plus 6h x squared plus 6h squared x plus 2h to the third plus 5 minus 2x to the third minus 5 all over h. I'm going to cancel out here in this step here so we can see it. So that's going to cancel out. That's going to cancel out. The 5s are going to cancel out, right? And so I'm left with, here I have my 6hx squared. I have my 6h squared x. And I have my 2h to the third, right? All over h. Now, if I cancel out an h, then I'm left with 6x squared plus 6x plus 2h squared, which is just going to give us that's going to be 6hx plus 2h squared. So then this is just simply going to be 6x to the second power. So that's going to be your f prime of x for number 19. Now for number 25, we have f of x defined to be x squared plus 2x. So we have x is equal to 3 and x is equal to 5. So the slope of the secant line is just going to be the average rate of change. So this formula here is the average rate of change. So the average rate of change for f of x from as x goes from 3 to 5 is 10 units. So then that's going to be the slope, right? And so we're going to use the point 3 and f of 3, which comes out to be 315. We're going to plug that into the point slope formula, and then we're going to get the equation, which is just y is equal to 10x minus 15. So again, we're going to use the average rate of change to get the slope of the line, and then use the first point, which in this case is x is equal to 3 and y is equal to 15, or f of x is equal to 15, or f of 3 is equal to 15, sorry. And then we get the equation, which is 10x minus 15. Now for part B, we're going to find the limit of the function, or the derivative of the function, as when x is equal to 3. So you can see how we just follow all of the steps, and we end up with 2x plus 2. Now, the next thing is, what is the value of the function when x is equal to 3, or the value of the derivative? So f prime of 3. So again, this is f prime of x. So then what's f prime of 3, which is given from this point? We get 8. 8 becomes our slope. And then we use the point 315 to get that equation, which is y is equal to 8x minus 9. For number 23, again, we do the same thing, right? The function is 5 over x, from x is equal to 2 to x is equal to 5. The average rate of change is -1/2. So in this case here, we're going to use the point 5 and f of 5 and the slope -1/2 to get the equation, which is that one right there. Then we calculate f prime when x is equal to 2, which we get -5 over 4. And then we just get the next equation, which is -5/4 x plus 5. Now, for number 49 is a word problem. What they're asking you to do is to find, so this is the demand function. And they're just asking you to find the demand for the product when the price is equal to 10. And so d of p is equal to -2p squared minus 4p plus 300. We find the limit as h goes to 0. We end up with -4p minus 4. We plug in the 10, so d prime of 10 just gives us -44. So there'll be a decrease of 44 units if the price goes up to $10. And I'm going to leave number 50 extra for you guys. Now, number 51, I'm just going to do the first one. Here they're asking us to find the derivative of the revenue function. And so the revenue function is 20x minus x squared over 500. R prime of x is 20 minus 1 over 250x, which is the same thing as saying 20 minus x over 250. And so then they found, okay, so what is the marginal revenue for 1,000 tables, I believe this was. And so we just plug in that value and we get 16, so it's going to be $16 per table. And that's the video for 3.4. Thank you.